This is the Section 3.6 review, number 6, the free response question, in which calculators are not allowed. So in part A, notice they tell you what dy dx is supposed to be. So you already know what answer you should get. If you do not get this legitimately, then you know you've done something wrong and you need to backtrack. So here we've got a curve given to us implicitly. So we've got to find dy dx by taking the derivative of both sides with respect to x. And we're interested in showing the process because that's what you will be graded on. So the first thing I'm going to look for, man, I'm messing up all over the place. First thing I will look for is whether or not you apply the proper operator. That means on the left and right you need to have the d dx. You do not have a dy dx because you haven't taken the derivative yet. You are just telling yourself that you need to differentiate with respect to x. So on the left here we see that we've got two different product rules. One of the errors that people will make is they will neglect this negative on the second term of the product rule for this one. So we got to make sure we keep that negative with the x squared. So for the first one we have a 3x times the derivative of a y squared. Well, that's the power rule times the derivative of what was squared, which in this case it's a y, so the derivative of that y will be a dy dx. So here's our first times the derivative of the second, plus now we've got the second one, which is a y squared, times the derivative of the first, which is a 3. So we've completed the product rule for this first term. Now we're going to move to the next one. So we have plus, the first is a negative x squared, the derivative of the second is a dy dx, plus the second, which is y, times the derivative of the first, which is a negative 2x. Now if you stop here and have an expression and then all of a sudden turn it into an equation later, you're also going to miss points because you need to have this equaling 0. So another mistake that people make is they neglect to take the derivative of the 18. You want to make sure you take the derivative of both sides of the equation. We end up with a 0. Now we've got to identify the things that have dy dx's in them. Notice that all the things that are multiplied by the dy dx are attached to it. So we'll have one term there and another term here. That means the other two will end up on the other side. So if I complete this, I will keep this on the left, which is a 6xy times a dy dx. And then that y cubed, or y squared times 3 will need to go to the other side. The negative 2xy will go to the other side, and we'll be left with the negative x squared on this side because it has a dy dx in it. Our next step is to factor out that dy dx. So I pull it out, and I'm trying to head toward here, so I'm going to put these in the order that we've got them here. And then I will isolate. Notice that we have arrived where we're supposed to. These two things match, so we know we're done. The point breakdown is you get 1 point for doing the implicit differentiation, including the 0, having the correct notation. And then you get another point for going through the process to isolate the dy dx. So that part is worth 2 points. Now we move to part B. Part B says we want to find all the points on the curve whose x-coordinate is 3, and then write the equation for the tangent lines that go through those points. So first thing we know is that the x-coordinate is 3, and it's supposed to be points on the curve. So I'm going to take that 3 and plug it in for x up in the curve equation. That'll give me a 3 times a 3 times a y squared minus a 3 squared times a y equals an 18. Well, my goal is to find the y's that go with those x coordinates of 3. So I'm going to multiply this out. I get a 9y squared minus a 9y, and I'll move the 18 to the other side so that I can start to factor. Notice there's a 9 in common. I can pull that out, and then I can factor. So if I factor that, I'll get a 9 times a y minus 2 times a y plus a 1 equals a 0. So now I have figured out that two of my points that have x coordinates of 3 are going to be used to create equations of lines. So the first one has an x coordinate of 3 and a y coordinate of 2. The second one has an x coordinate of 3 and a y coordinate of negative 1. Because if I solve this, I have two factors multiplying to give me 0. So either y is 2 or y is negative 1. So now I've got my points. The goal is to find the points, which I've done, and then write the equation of the tangent line. So in order to write the equation of the tangent line, I need to evaluate the slope, which is given by dy dx, at the point 3, 2. Well, here's why they gave us the slope here, because if they didn't give us the slope and we messed up, then that would make a nightmare for grading for whoever wanted to grade this problem, because then you'd be plugging your point into the incorrect slope, which would give you the incorrect line. So at this point, it's simply arithmetic, and I would bet that at least a quarter of you will make stupid arithmetic mistakes. So be very, very careful when you're evaluating that slope at 3, 2. This says that the x is 3. So every time there's an x, I'm going to put in a 3. Every time there's a y, I'll put in a 2. X is a 3, y is a 2, x is a 3. So if I simplify this now, I've got a 12 minus a 12. What do you know? I get a slope of 0. So using the slope and the point, I can write y equals the slope times x minus the x coordinate plus the y coordinate. Or you could see, since the slope is 0, it's just a horizontal line. So let's think like a math teacher. Let's think about someone who has to write multiple versions of these tests. One option here was ending up with a slope that was 0 and a horizontal line. The flip side of that is, what if the slope is undefined? In other words, instead of having the top turn into 0, what happens if the bottom turns into 0? If the bottom turns into 0, we would get an undefined slope, which means we'd have a vertical line, x equals 3. So kind of as you're doing these problems, think about how a teacher might twist the problem and give you the same sort of skill in a different setting. So we also need this slope for the second line. So we've got the point is 3, negative 1. So the slope for the second line will be dy dx evaluated at 3, negative 1, which means wherever we have an x coordinate, we're going to put a 3. Wherever we have a y coordinate, we're going to put a negative 1. So I'm going to refer to this slope right here because I've got it written. That'll be a 2 times a 3 times a negative 1 minus a 3 times a negative 1 squared is a positive 1. On the bottom, I have a 6 times a 3 times a negative 1 minus a 3 squared, which is a 9. Simplify that, I get a negative 6 minus a 3, that's a negative 9. And on the bottom, I have a negative 18 minus a 9 is a negative 27. So if I put that together, I end up with a slope of 1/3. Point and slope together, I can make the equation of the line y equals the slope, x minus the x coordinate plus the y coordinate. Now let's look at the breakdown of points. You get 1 point for plugging 3 into the equation of the curve. So this would earn you your point, or this would earn you your point, or this would earn you your point. Doesn't matter, any of those 3. That's 1 point. Then you get another point for solving for your y and figuring out that y is going to be 2 and negative 1. Your final 2 points come from the equations of the lines, and you're either going to get it or you're not. So you get 1 point for that line and 1 point for that line. No partial credit, you get it or you don't.